Hi, I'm Arvind. So today topic is performance evaluation matrix. Before this topic, we can learn the evaluation matrix. So in previous video, we will all discuss about what is metrics and evaluation matrix all about and its types of metrics. There are two types: classification and regression, and we'll discuss the types of classifications and regression also, and we can I will show the one code to both regressions metrics regressions. Okay, so in this topic we can learn performance evolution matrix. So what are the performance evolution matrices? So definition performance evolution matrices are tools used to measure how well a machine learning model is performing. They help you to understand how accuracy or precision your model is, whether it make correction or predictions, how much error is in predictions, if it is biased towards certain classes, how much error is in prediction used for regressions, and another in used in classifications. So performance evaluation metrics in machine learning. So performance metrics help us to evaluate how good your model is. So in classification metrics, these are the type: accuracy, presence, recoil, F1 score, confusion matrix, ROC mat. So in classification matrix, accuracy means overall correction prediction. These all are already discussed in previous video, and I will discuss in simple way. So presence means out of predicted positives, how many are corrected. Recoil means out of all actual positives, how many were found. F1 score means harmonic mean of the present and recoil. Confusion matrix means so TP, TN, FP, FNRS, ROC, AUC means ability of model to separate classes. And another one is regression matrix used when it is predicted continuous values. Example: temperature scales. MAE means average of absolute predicted errors. MSE means average of square predicted prediction errors. RMSE means square root of MSE. R square score means how much variance is explained by the model. So it is the code of both regression matrix and classification matrix. So first to import the Python libraries. So first we see the classification matrix. So first we load the data set and we split the data x train and y test. X train and we here simply we set that train and test the data. So we will give the testing size equal to 0.2 and random split equal to 42, and we use the logistic regression model. Okay, here we stored the predicted values in y predicted and probability in y underscore prob values. So here metrics are accuracy, present, recoil, F1 score, AU score. So in confusion matrix, this is the code to find the values of their types of like accuracy, present, and all about. And ROC, this is for ROC. We are using two labels: false positive rate and true positive rate. ROC curve plot, this is code for ROC curve plot. And another one is regression matrix. So regression matrix, here we load the data set and split and train the data set. Here testing size is 0.2 and random set is 42, and here we use the linear regression model, and we store the y values in y underscore pred. And here the matrices are MAE, MSE, RMSE, R square. So we draw a actual. So we draw a plot between actual and predicted values. So this is the output for classification matrix. So accuracy is 1.0, precision is 1.0, recoil is also 1.0, F1 score also 1.0, AU score also 1.0. This means this model is perfect. Train and test and predict the values. And this is the confusion matrix. Actual and predicted values. between the it is predicted the values between actual and predicted values and the ROC curve. This is also this is the values are true positive rate and false positive rate. So this graph is predicted between these two values. And another one is regression matrix. So here ME is 42.79, MSE is 2900.19, root mean square error means 53.85, R square means 0.45, and this is the graph, predicted graph. So this value, the two values are x-axis is actual values and y-axis is predicted values. Thank you. Hmm.